The X-ray multi-mirror mission, XMM, due for launch in August 1999, is the second cornerstone project of ESA's Horizon 2000 long-term science program. The payload is primarily made up of 3 telescopes with their optics called mirror modules, consisting of an assembly of 58 nested X-ray mirrors, which represent the major technical challenge of the spacecraft. The 3 mirror modules are developed under direct ESA contract by a consortium of European industries led by Media Lario of Italy. X-ray mirrors are thin gold-coated nickel shells. They are shaped to a paraboloid surface in front and an hyperboloid surface at the rear. Incoming X-rays are reflected at grazing angles, first from the paraboloid and then from the hyperboloid, before converging to the focus. The 58 mirror shells, with diameters of between 300 and 700 mm and a height of 600 mm, are nested in a confocal and coaxial configuration. Thicknesses of the mirror shells are less than 1 mm. Mirror shell manufacturing is based on a replication process, which transfers a gold layer deposited on a highly polished master mandrel to an electrolytic nickel shell. The production cycle starts at Carl Zeiss plant in Germany with the manufacturing of the necessary 58 master mandrels. The aluminium mandrels coated with a Canigan nickel are lapped to the exact shape required for each mirror. The mandrels are finally super polished to a surface roughness better than 4 angstrom. The diameter of the mandrel is measured with reference gauges. Axial profile measurements are measured to an accuracy of 1/10 of a micron. The circumferential profiles of the mandrels are also verified. Finally, the mandrel surface roughness is measured using an interferometric microscope. On this mandrel, the roughness is better than 2 angstrom. After final inspection, the mandrels are transported in special containers to Media Lario in Italy for the manufacturing of the mirrors. Media Lario is a medium-sized company of about 50 persons. They are responsible for the manufacturing, the integration and the verification of the X-ray mirrors for XMM. The first step of the mirror production is to coat the mandrel with a thin layer of gold. The gold deposition is done in a large vacuum chamber. The mandrels are transported to the gold plating facility, where they are inspected and thoroughly cleaned by hand before the start of the gold evaporation under vacuum. The gold-plated mandrel is taken out of the vacuum chamber. It is then prepared for the nickel electroforming with the mounting of electroforming tools. All these operations are carried out in a clean environment. The mandrel assembly is now dipped in the electroforming bath. Bath parameters and electroformed nickel properties are constantly verified. Three to 4 days later, the gold-plated mandrel with a nickel shell of less than 1 mm is taken out of the electroforming bath. Immediately after the electroforming process and the dismounting of the electroforming tools, the mandrel is installed in the release stand. The mirror is then separated from the mandrel and is carefully raised. The released mirror is then transported to the metrology area, where it is suspended with the active suspension device which controls its shape. The optical quality is assessed by geometrical and surface micro-roughness measurements. The optical surface of the mirror is mapped by taking a number of circumferential and axial profiles. The analysis of these measurements gives a prediction of the optical performance in terms of resolution. Then, the roughness of the mirror surface is checked using an interferometric microscope. Before storage, the mirror is visually inspected to verify its cleanliness. Meanwhile, work goes on in Switzerland at ABCO on the structural parts of the mirror module. An aluminium structure is manufactured and assembled. This structure, interfacing with the spacecraft platform, will be mounted on the spoke wheel after the integration of all the mirrors. The spoke wheel, on which the mirrors will be integrated, is machined by turning and by electro-erosion. The spoke wheel geometry is controlled with a high-precision 3D measurement machine before delivery. Back in Italy, the integration of the mirror shells on the spoke wheel is performed by media lario in the vertical optical bench. The mirror is suspended with the active suspension device and carefully positioned above the spoke wheel. The position of the mirror is then laterally and vertically adjusted to fit in the corresponding grooves of the spoke wheel. The optical performance of the mirror is continuously monitored and compared with those obtained just after the release from the mandrel. The mirror shell is then glued inside the grooves of the spoke wheel. Epoxy glue quality and quantity are carefully monitored to avoid distortion of the mirror at its edges. After the curing of the glue, the optical performance of the mirror is again verified in order to check that no degradation has occurred. After completion of the integration, the mirror module is transported in an ultra-clean and air-conditioned container to the Focal X facility at Centre Spatial de Liège in Belgium. Focal X is a vertical optical facility which has been especially designed for the XMM program in order to calibrate the performance of the complete mirror module in extreme ultraviolet and in X-ray. The mirror module is prepared for the optical tests. After the last verifications, the mirror module, mounted on the test adapter, enters the vacuum chamber of Focal X for the optical measurements which are performed at different wavelengths. The analysis of these measurements will verify the performance goals of the XMM mirror modules.